Alrighty, right at the start here of your test on Friday, you're going to see write each polynomial in standard form, classify it by degree, by number of terms, and describe the end behavior. So, is it number 1 already in standard form? What's wrong with it?
2/3 power.
Oh, well, we better put those together. What would we get?
1.
1 next to the third, and what goes next?
Minus 5x squared.
And our little tag along at the end of the minus 1, right? Now, people get confused because they're like, it says classify by, and then it has a little colon. Does that mean I write stuff there? No, 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 no. Remember, we're going to classify by degree and by terms. So that's where the names go. What is this called based on its degree? It is a cubic. That's a little 3 right there. The highest power, which is the degree. How about by the number of terms? A trinomial. 1, 2, 3 terms. Trinomial. And now the end behavior. And we're not going to take the graphing calculators away from you for this test, so you really could just graph that. X cubed minus 5x squared minus 1. But that's not what I hope. My hope is that you look at this and say, okay, it's a cubic, it has a positive in front of it, its end behavior is going to look like that. So as we go to the left forever, where is our graph going? Down. And how do you use infinity to say down? Negative infinity. Negative infinity. As x approaches infinity means if we go to the right forever, where's our graph going to go? Positive infinity. Yeah, it's going to go up. Go up. All right, there's another one of these. Is that one already in standard form? What's wrong with it? They are out of order. Yeah, we have to have the highest power first, and then you work your way down by powers. So it should look like that when we're done. This one we can't define anything. So classify it by degree, it would be called a quartic. Quarter. Quartic. By the number of terms? Trinomial. 1, 2, 3 terms. Okay, everybody. If you see a problem on the test that says this is your polynomial in standard form, what is its name by degree? Constant. And what's its name by the number of terms? Monomial. What's something that has 2 terms called? Binomial. 3 terms? 4 terms? Polynomial of 4 terms. Yeah, that's where we start saying polynomial of 4 terms, polynomial of 5 terms, etc., that kind of stuff. Degree 1 polynomial, classified by degree. Degree 1 is called? Linear. Degree 2 polynomial is called? Quadratic. Degree 3? Cubic. Degree 4? Quartic. Degree 5? Quintic. Quintic. So that's about as high as we went in here. Now, this one is a quartic, so that means it's degree 4, which is even, and it has a positive number in front of it. So its end behavior is going to look like that. That's its end behavior. So as we go to the left forever, what do we need to put in this little slot? Infinity. It's going up. How about as we go to the right forever? Still infinity. It's still going up. So that's its end behavior. So, a couple of those on the test, just like that. Where it's, basically, can you remember all the namings? Can you remember your end behavior notation? Bless you. All of that good stuff. So let's go down to the next one, and it says, find the relative max and relative min of this function. Well, how do we do that? Yeah, we have to. Remember, even through pre-calculus, you got to use the graphing calculator. So let's plug her in. Use parentheses for the lovely little fraction that we see there. So parentheses 1 divided by 2 parentheses. X to the third minus 2x minus 2. And I'll try a zoom 6. What I want to see is I want to see a little hill and I want to see a little valley. Oh, cool. Got both. And we'll be able to answer both. How do I get the calculator to tell me what the little hill is? Second trace. For the hill, what do I use? Max, number 4. And then Blinky tells you exactly what to do. Blinky says left side of the hill, enter. Right side of the hill, enter your guess. And we'll just go to hundreds, so 2 decimal places. Negative 1.15 and negative 0.46. Okay. How do we get the calculator to tell us the value? The value. And the second trace, number 3, and left side of the valley, right side of the valley, enter your guess. 1.15 and negative 3.54. So that's totally graphing calculator. You're going to have actually 2 problems on here. I think you have to know how to use the graphing calculator for those pieces. All right, let's look at write a polynomial function. So this says we're going to write a polynomial function with rational coefficients so that p of x equals 0 has the given roots. Ooh, they told me what I have to call it. They said it has to be called p of x. Now, it did say polynomial function, so that usually means f of x, g of x, h of x, any of that stuff. But they specifically mentioned p of x, so we better use p of x. Now, how on earth am I supposed to do that if they just tell me it's 3, negative 3, and 1? What do we use for the 3? X equals.
Minus 3.
There we go. What do you use for negative 3? X plus 3. And how about for the 1? And we are going to save a lot of time and effort if we know which 2 of those to multiply together. Exactly. Use that sum and difference pattern. Make your life easier. Do that first. So that's going to give us x squared minus 9 times x minus 1. And then you realize one FOIL away from having my answer here. I just need to do FOIL. So x to the 3rd minus x squared minus 9x plus 9. And that would be what we put in the blank. Kind of checkable. I mean, you could plug this into your calculator and see that it crosses at negative 3 and 1. There's a lot of polynomials that do that, but at least you have an idea you're on the right track. All right, so that one, no tricks to it. You just think backwards about your linear factors and you multiply. That's what you do. But with number 5, it's not a trick. It's a knowledge question. And that question is, if the square root of 2 is there, what else is there? Negative square root of 2. We're not going to tell you both of those. You have to know that. And if 3i is there, what else is there? Negative 3i. That only happens with the radicals, the square roots, and the imaginary, not normal numbers. Like if there's a 2, that's just 2. You don't do anything else. So we got to call this p of x again. And we've got to use x minus the square root of 2, x plus the square root of 2, x minus 3i, and x plus 3i. And then once again, if we know how to group these, this is going to be a very basic problem. How do we group this? 2 radicals first, then 2 imaginaries. So you're using these 2 and these 2. You want to use that sum and difference pattern to make life easier. So first times first, x squared. Outside times outside and inside times inside cancel out. Don't even bother doing it. In the back, we would have a negative square root of 4. Then you're going to multiply x minus 3i and x plus 3i. Well, first times first is x squared. You realize I don't have to do outside times outside and inside times inside. But in the back, I'll have minus 9i squared. And then the little light bulb above your head shines. And you go, oh, wait a minute. I know what the square root of 4 is. That's a 2. And hopefully you remember something that's going to help you in the second set of parentheses. What's that something? I squared is -1. So -1 times -9, we'll make that a plus sign. And again, you're one step, one FOIL away from having your answer. X squared times x squared, x to the 4th. Outside times outside is 9x squared. Inside times inside is minus 2x squared. So that's going to be 7x squared. And then -2 times 9 will be minus 8. There it is. Now this one, you can't really check because it had imaginary zeros. You could figure out that the square root of 2 is 1.4, blah, blah, blah. And you could use your calculator to check that and negative square root of 2. But you shouldn't see any other spots where this crosses the x-axis because the other two are imaginary. And imaginary don't show up on a graphic calculator as x-intercepts. So one more for the front page, and I think this one's pretty basic. Find the zeros of each function. State the multiplicity of any multiple zeros. Anywhere there's an x, there's a 0. So what's the 0 for that little negative x out front? 0. So it's 0, 0, multiplicity of 1. It's an x to the 1st. Now normally we wouldn't even write that down because it doesn't have multiplicity if it's a multiplicity of 1. But because it's a test and you want to know that you understand stuff, you probably should do that. Next set of parentheses, what's our 0? 3, 0. Multiplicity of 5. The power of 5 out there. One more to go. Might take a little bit of work. You might have to write down 2x minus 5 equals 0. Add the 5, divide by 2. To get that one. So 5 halves, multiplicity of 2. So that one would be a bouncer. Anytime we have an even multiplicity, we're going to just be tangent at the x-axis, and that's why. That one's done. In fact, that's the front page. So right now, I want to stop and just have you focus on that front page and give me your level of comfort here. 43210. How are you feeling about the front page? Okay, now we are reviewing for 2 days, and I know what's bothering those that have the lower numbers. Cubic and then the quadratic formula. Well, you've got to memorize the formulas for the cubic so that you can get those down. And we already did the quadratic formula before, and I know you were great with the quadratic formula because you did great on that test. So it'll come. Give it time. Now, those of you that are great factorers, this back page is for you. That's what this is about. Find the real and or imaginary solutions by factoring, and you have to show your work. So taking a look at number 7, what would you do first? Take an x out. Jake and Chase, pay attention. We will take an x out, and it will look like that. And we will hope we are not done factoring. We would like to get all of these as easy as possible. But that's not a perfect square trinomial, so we have to go to good old-fashioned factoring and hope that we know 2 numbers that multiply to -4 and add to 3. Yep. And we don't have any squares, so we're done factoring. Now it's about, can we find the zeros? What's the 0 for that one out there? Yep. How about that one? And that one. Now I'm writing them this way because I want you to know we're going to accept them both ways. If you write down 0, 0, -4, 0, and 1, 1, or 1, 0, you'll get the points. If you write down x equals 0, x equals -4, and x equals 1, you'll get the points. So just pick away and stick with it. There are the zeros for that one. Number 8. What do you see? Perfect cubes. Yeah, I can see everybody's trying to get those right now. So what do you cube to get x cubed? X. What do you cube to get 27? 3. We've got an x and a 3 for our a and b. First set of parentheses should have a plus or not? Yes, this has a plus, x plus 3. So when it's a cubed plus b cubed, it has to be a plus b in the front, but then a squared minus ab plus b squared in the back. So this will be x squared minus 3x plus 9 equals 0. One of these is super nice. It's this one. What's the 0 for that one? Negative 3. The other one, not so nice. We're going to have to complete the square or use the quadratic formula. This one would not be a nice candidate for completing the square because it does have a fraction. We take negative 3 and divide it by 2 and square it. So most people would probably just use the quadratic formula. So A is 1, B is negative 3, C is 9, and X equals negative B. So negative of negative 3 will be positive 3, plus or minus the square root of negative 3 squared is 9, minus 4 times 1 times 9, all over 2 times 1, which is 2. 9 minus 36. What is that? Negative 27. So x equals 3 plus or minus the square root of negative 27 over 2. And now we have to see if we can go ahead and simplify the square root of negative 27. So we've got square root of negative 1. Do we have any perfect squares? What do you use? 9 and 3. So tell me what that's going to be simplified. 3i square roots of 3. So we've got 3 plus or minus 3i square roots of 3 over 2. Can we simplify that further? No, 3 is not divisible by 2. Not nicely anyway. You're not going to get a nice integer out of that. So we've got the really nice 0 of negative 3, 0 back up here. And then we've got a couple of ugly ones at 3 plus or minus 3i square roots of 3 over 2. That took some space, huh? I'm going to have to erase this to go after 9 and 10. I'm going to need more time for number 8. Alright. I will erase. And let's put this up. Number 9. Greatest common monomial factor. Can we pull anything on all of those? So what catches your attention about this one? It has 4 terms. How do we do that? Grouping. All right. Do you have anything you can pull out of x cubed minus 2x squared? What you got? Biggest one is x squared, everybody? Yep. Okay. What's left when you do that? Good. Back 2. What do you take? A 3. What's left? Which has to be exactly the same as the first set of parentheses. Remember, this is tricking our brain into seeing that x minus 2 really is a 0. Now, that means we're short one set of parentheses. What goes in the other set? X squared plus 3, the leftovers. Well, this one is nice and easy now. What's the 0 for x minus 2? 2, 0. X squared plus 3, is that factorable? No, so we'll have to do x squared plus 3 equals 0. How do you solve that? Subtract 3, then square root it, and figure out how to simplify it. Plus or minus what? I square roots equal. So 1, 2, 3 answers. Cool. Let's go after number 10. All right, something just looks wrong about number 10. What's wrong with it? Gotta have a 0. Yeah, that 81 needs to move over. So x to the 4th minus 18x squared plus 81 equals 0. Greatest common monomial factor. Can we take anything on all those? You know what? This might be a perfect square trinomial. We've been testing for that a lot and we haven't found it. Let's try it. X squared squared, 9 squared. If you take x squared times 9 and double it, what do you get? We finally found one. It's a perfect square trinomial. It gives us 18. So this will be x squared minus 9 squared equals, wait a minute, x squared minus 9 even factor. What does that factor in? X plus 3 and x minus 3. So what are our two zeros? Negative 3 and 3. okay, but hold on. Uh-oh, we must have done something wrong. We're supposed to get 4 zeros out of this thing. Add it. You can. It has a multiplicity of 2. That's what this power is. That means each of these gets to count twice. So we did get all 4. We've got it. So that's some definite extra factoring there. You know, it's definitely a step up from what we've done in the past. But if you were really good at factoring before, this should not be that awful. Alrighty, looks like we've got a graphing calculator problem coming up here because it says use a graphing calculator to find the real zeros of the equation. When necessary, round to the nearest hundredth. So my question would be, is this set to go into the calculator? How can go? This has a 0. It has a 0. So we have to have the 0 before we can plug it in. And calculator, we need x to the third minus 4x squared minus 7x plus 10. Zoom 6 and hope for the best. Hope that we get to see 3 places where this process is. You know what? They might be perfect. Doesn't that look like -2, 1, and 5? Well, then I'm not going to use Blinky. I'm just going to go to the table. -2. There it is. -2, 0. 1, 0. And I'll scroll down a little bit because it looked like the other one was at 5, 0. There it is. Now, let's just say you didn't notice that. You definitely could still use Blinky and hit second trace, number 2. Make sure Blinky goes to the left of the intersection. Enter, right of the intersection, enter, enter if you guess, but look, you get the exact same answer. So tomorrow, we'll have one on a practice test that's not perfect, like this one is, so that we have to use Blinky to find it. Because you could see it both ways. You could have some that are super nice, and they come right from the table, but you probably have one that's definitely going to be a let Blinky take care of it type of problem. All right, so backside, just the backside now. How are you feeling? 4, 3, 2, 1, 0. All right, well, if you've got these side numbers today and we have one more day to practice, I think you could be looking pretty doggone good on Friday. I'm going to give you one review assignment to cover both days. Just one review assignment for both days. So you might want to do a little bit of this tonight. Tomorrow we'll go through another practice test.